The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
What? Who turned this up to 67? 62 is just fine. You know, speaking of thermostats, energy efficiency is kind of an interesting topic. So in today's episode, we're going to build the chimney of the future. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
Everyone loves a nice, cozy fireplace, and it's a great place to store your junk mail for free heat. However, I've heard they're not very efficient, and Mythbusters proved this in a test. They had a fireplace, and it sucked air out of other parts of the home toward the fireplace and out the chimney. So that got me thinking, the chimney is kind of inefficient. It gets warm, but all it's really doing is pulling, the smoke out of the house. What if we could use the warmth of the chimney as part of our heating solution? So in today's episode, we're going to test just that by making a model chimney and home. So normal chimney, heat just radiates out of it, blah, whatever, and smoke comes out the top. We're gonna do this, we're gonna make a chimney, but it's gonna have special blocks with more surface area. And this is the special block I designed. Just like the heatsink in your computer, the more surface area you have, like fins on your heatsink or a radiator in your car, the more surface area you have, the more heat you can pull away from it. In the case of a car or a computer, you want to keep the CPU cooler, or in this case, we want to pull heat out of the chimney and use it. So to claim that heat, we're going to enclose the bricks in a large tube. We'll probably just use a piece of PVC, but I don't know what it would be in an actual house. And the idea is the cold air will be pulled in here, and as it rises and heats up by pulling heat off the bricks, it'll come to the top, and then we'll have a forced air fan here. Down here, we'll have a sensor on the return vent. Once the home gets too cold, it will activate the fan or speed up the fan to force more warm air through the home. So we're basically using natural convection. I guess it's not natural because you lit the fire. So basically we're using convection to heat up the air using the surface area of the chimney that might otherwise be wasted. Then we're going to force it through a vent system. There's a few steps to this. We're going to cast some bricks, make a model chimney, and then build a model house around it to see if it gets warm. And of course we'll use a microcontroller and a thermistor to actually do the temperature sensing and fan control. We 3D printed a bunch of molds that we could cast plaster of Paris bricks out of. Felix is demolding those now. While he's doing that, I'm going to manually create a mold for the fireplace itself. Time to cast the mold. I'm going to use up this last bit of plaster of Paris here and get a free stirring bucket out of the deal. Awesome. I don't know exactly what the volume is, so I'm just winging it. Who could it be now? I've already made quite a few bricks out of the plaster of Paris. What I learned was you can actually mix it fairly thin. I would say like even thinner than pancake batter. And that makes it easy to pour. So it doesn't have to be super thick when you pour it. I mean, this mold's actually a lot more simple than the other molds, but I want to make sure that it fills in behind this chamber as well. So yeah, if it's a little soupy, that's okay. We could use this to turn you into a mummy. Then you could never leave. What do you think? Then we'll use the mold to build Alex robot. It will have your muscles and Felix's brain. Gross, right? I'm using WD-40 as a release agent, so, you know, we can easily pull the mold apart. The bricks were plastic, which would have a higher surface tension than this paper. Granted, we're not going for looks with this thing. Now we will find Bigfoot's footprint. Well, I made my plaster of Paris too thick and it's set up too fast. It's already congealing here in the bucket. I'm not sure if this is void free, so I think I'll make another mold and try it again, just in case. I'm going to build the fake house enclosure now, using this foam core to create the walls, a wooden base, and there will also be sides to it, like this. And we're also gonna put in vents, but I'll do that after I make the main structure. And then we're gonna use this leftover dog door to enclose it from the front, but have it be see-through. Hopefully we can look through this to get a thermal image as we're doing our heat simulation. Here's our base fake house frame. We'll put the stove in there and the chimney up here. Once we know exactly how tall the chimney is, we'll cap off the top of it. And we'll also seal the front with a removable door so we can get at it, but then of course close it in so we have a static environment inside. So we'll have to make this removable and nicely sealed. All right, now we're gonna demold the fireplace. Yesterday, I cast these two molds. This one was a little thick. This one was a thinner mold that will probably look better. The main problem with this one is there might be air pockets or voids in it. So I'm gonna cut out the foam core and see how they worked. Still feels kind of wet. See, there's a void right there, but it's not terrible. Yeah, the voids on this one are pretty bad. I don't think this one's gonna cut the mustard. Oh no, that's a foil. That's what Dave Jones would say if he were here. Also, that was a long plane ride. Hopefully we have better luck with this one. That's a win. Stuff. Oh, doesn't that Hobbit movie come out this weekend? The Hobbit Part 10. Oh wow, that Vaseline. I used Vaseline for a release agent on this one and that worked great. Oh, I'm sorry. I used petroleum jelly as a release agent. Well, because it wasn't Vaseline, it was generic petroleum jelly. Oh, look at that surface. Smooth as petroleum jelly. Hey, remember that ad for Plumper? Hot dogs. There's a little more to love in a plumper, 'cause there's a little more plumper to love. Well, that's how the ad went. Wow, that Vaseline works really well. What about Big Red? You remember those old commercials? Maybe you're too young. The Big Red Freshman gets right to you. It's good, tastes good, on and on. While you chew it, so sit by a little longer. Say goodbye a little longer. Make it last a little longer with Big Red. It's just like art class, except for I'm not getting detentions. Problem with this back piece is I don't think it has as much release agent on it, so it's kind of... Yeah, I was gonna say we should burn it. Yeah, you know what? Yeah, screw it. It's gonna be a fire anyway. And that's how the pyramids were built. Okay, I'm gonna clean this up and get ready to put the blocks on. I'm gonna mix up small batches of plaster of Paris and then start attaching these bricks one by one to my fireplace base. I definitely do not know what I'm doing here. I'm having to find the right consistency and thickness of the plaster of Paris in order to use it as kind of a glue. Yeah, it's like basically you can't really make it thin enough because even if it seems too thin, it still congeals pretty quick. I really haven't done anything with plaster of Paris probably since I was in kindergarten, so it's all new to me. Wasn't wet plaster how Michelangelo painted? I mean, before he became a Ninja Turtle? Whoa, you didn't know The Last Supper was painted by a Ninja Turtle? Come on, Allison. Splinter, he invented the tank to fight the Foot Clan in Renaissance Europe. He's like, true ninja is of the body, not the mind. Raphael. That was cool at the end where Splinter fought Shredder. He's like, death comes to us all, Orokusaki. But for you, something far worse. For when you die, it will be without honor. We have the bricks together and they're fairly straight. The issue with them being crooked was that the tops of them weren't level, but it's pretty decent. It's good enough for a test. And now I'm just using a thin plaster of Paris slurry to paint the cracks on the outside to help seal it and keep it in one piece. I put the completed chimney into this foam core box, which is going to represent a house. And it has a plastic front in it that can be removed. We can't get a thermal image through the plastic front because it'll bounce off the plastic surface, but this allows us to keep an eye on the fire. We've got it near the door, the fire extinguisher, and a bucket of water just in case. And we're using these little fire starter bricks, which are kind of like waxy sawdust bricks, and these will simulate our miniature fires. We're going to run a control test first. We're just going to run the chimney and see how warm the surrounding area gets after 30 minutes. Jack London would be proud. Definitely feel a lot of heat coming out of the chimney, but of course that's smelly heat. We want clean heat, so to speak. Allison, start the timer. Okay, we're gonna let this run for 30 minutes or until those 2 bricks burn out, and then we'll take a look at the thermal image. Oh, wow, of the unit. Okay, that's a bit smoky. Okay, it's been 30 minutes and 3 different bricks. Let's take a look at the temperatures. If I look at it just like this, I see the front panel, so I've got to open it up to actually see what the warmth is inside. Oh, we should have put like little model furniture in this. Okay, so the fireplace itself is very hot. It's around 300 degrees. And the chimney is quite warm as well. Looks like it averages about 169. I'm looking around the inside of the fake house. Feels pretty good. The walls are around 70. Floor is around 73. Of course, it's probably getting heat from the chimney. And of course, these aren't insulated, so they're actually pretty decent considering they're right outside And outside it's about, I don't know, 20 degrees. It's actually kind of a cold day. All right, so I'm just gonna go over here. Okay, so I got the right wall, let's say 72 degrees on the floor. Yeah, the floor is about 70 to 72 degrees. That's our control test. Next, I'm going to build the enclosure around the chimney that will have a microcontroller and forced air to take the heat from the chimney itself and radiate it in a more efficient manner inside of the home. And of course, it's a truck running outside. With the physical part of the project done, I can now work on the electronics and the code, which are both very simple. I have a thermistor on an Arduino here, and I'm mapping its temperature to a fan speed. So if the temperature drops below a certain set value, like what you want your thermostat to be, the fan will turn on. And the lower it is from that target, the faster the fan will go. On the screen here, I have the values. The 200, the number on the right, indicates how fast the fan is trying to spin. So if I hit it with this ice cube, you can see it's going to try to spin very fast. And as it warms up toward the target temperature, it will not have to spin at all. So I'm going to take those numbers, map them to PWM to drive the fan. Hopefully that fan works with PWM. And then we will build it into our chimney house. I've taken my breadboard circuit and attached it to our model home. So we're going to light the fire again, but this time all the heat from the chimney will hopefully be piped down into our miniature vent system and warm the home. And I have two chairs here. They're both the same distance from the fireplace, but one of the chairs is in front of our forced air reclamation system. So let's see if we find a difference after 30 minutes. Let's talk more action. I also added a thermostat knob so I can adjust the speed. Since I don't actually know the temperatures we're going to get, I want to make sure I can keep the system running. I also added a little light, an LED, that would tell me if the fan's running or not, since, yeah, I can sort of hear it, but the LED tells me for sure. Let's see what happens. My shop will get cold, that's what will happen. It's been about 30 minutes and we've gone through 3 fire bricks. Let's take a look. I've increased the speed of the fan throughout, which means it did keep getting hotter and hotter. And I'm going to also record using this Seek thermal imaging camera for cell phones. Let's open it up. See a lot of condensation here, that's good. All right, so where our vent is coming in, the vent itself, the opening is about 104 degrees. And take a look at this nice toasty chair next to it. 84, 82, the floor is about 86 compared to our other chair, which is 73, 72, floor is about 72. Let's get like a wider view here. Yeah, see the all the heat over here. Obviously we can't see the temperature of the air, we can only see the temperature of surfaces with this camera, but it's quite a difference. And remember, the side walls are not insulated at all. Our PVC pipe got fairly warm, up to 97 degrees at the top. Of course, that's where the fan is. And our vent is warm too, which I guess is probably what happens in any home. Yeah, that's quite a difference. It looks like that actually works. By reclaiming the heat coming off of the chimney itself and cycling it through a vent system, we are able to more efficiently heat areas of our model home. I wish my shop was as toasty as this is because it's pretty cold with this door open. Ironically, we had to make the shop cold in order to do an experiment regarding heat. Today's challenge was to build a heat reclamation chimney. We started by making a model fireplace, and then we put a chimney on top of it. To do a control test, we lit a fire in the chimney for 30 minutes to see how it would heat up our miniature home. And we took a thermal image of it that we could compare later. Then we put on the recycling system, which has a shaft around the chimney, so air is forced up around the chimney, picks up heat from the surface, and then recirculates it efficiently through the home. The result was that it did indeed pick up a lot of heat from the surface of the chimney and heat up things around the home. So it was a success, at least in model form. So I'm happy with that result. What I would do differently, maybe cast the blocks a little better. I mean, I did that a little sloppy. Maybe make it look like more of a home, put some objects in it, put like a second story in it. But you know, for a first test, I think it was a pretty good result. However, what do you think? What would you do differently? Or do you have any other ideas about home energy efficiency? Let us know on the Element 14 community. That's all the time we have for today. In our next episode, we're going to be working with FPGAs. We'll see you then. You want a taste? Inside the meat pockets was a powerful sedative. You will go into a deep sleep. And when you wake up, well, you'll be inside a robot. You're like, man, my muscles, it feels like I work out all the time. About the right consistency. Let me just get the lumps out, like your mom's gravy. How do you feel about Bigfoot's, Allison? This looks like a chocolate shake. Oh, shake break. No, your nose obviously has an alien implant in it. That's the most logical explanation. It's a superconducting alien probe. Generates no heat on radar. The Vaseline worked great as a release agent. The petroleum jelly worked great.
Sorry.
You will never know my plan. Fireplaces are cool and they're a great... Fireplaces are awesome and it's a great way to achieve heat from things like phone books and political ads. I've always liked phone book logs. Fireplaces are great, and with all the free junk mail you get nowadays, Fireplaces are great. They're fun to sit by, and you get free fuel from them. Fireplace.
Drunk.
I'm still drunk. See, I can stick my hand here without it burning up.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.